Okay, continuing with the questions for section 16. Question 3 here. So which are open in R and which are open in Y? Well, A here is, what is it? It's like -1 to -1/2 union 1/2 to 1. B is -1 to -1/2 union 1/2 to 1. C is the other direction, -1 to -1/2 union 1/2 to 1. D is -1 to -1/2 union 1/2 to 1. And Z is -1 to 0 union 1 to 1/2 union 1/2 to 1/3, etc. And so then if we look at in R and Y, A, B, C, D, E, make ourselves a little table like this. We see that A is open, not open, C is not open, D is not open, and E is open. Whereas Y, if we restrict ourselves just to -1 to 1, then not only is Y open, but B is open as well. Because it doesn't matter if -1 and 1 are close endpoints in R, there's nothing outside of it in Y. But these guys are not open, not open. This is still open. Okay. Okay. So obviously, whatever argument works for pi1 is going to work for pi2. So let's just show it for pi1. So if U is open in X cross Y, then U is some kind of union of sets of the form U alpha cross V alpha, where the U's are open in X and the V's are open in Y. So if we look at the image of U, then that's pi1. Pi1 of U is equal to pi1 of this union of U's and V's, which is going to equal the union of the individual images, which of course is just going to be the union of the U alphas, which is an open set in X. Okay, and that shows that. And of course, you can't use this this argument will fail to show that it's a closed map. And in general, actually, it is not a closed map. Okay, for this one here. So if we've got, let's do A first. Oops. So if we've got V, an open set in T, and U, an open set in the topology for U, then V cross U is a basis element for X cross Y. But since T is in T prime and U is in U prime, this is also a basis in X prime cross Y prime. So anything that is open in X cross Y is also going to be open in X prime Y prime. Okay, and for B, what is it? If the topology on X prime cross Y prime is finer than the topology on X cross Y, then yes, the individual ones are going to be finer because we just used the previous question because the projections are open maps. Okay, and so if V cross U is in some topology, say topology of X cross Y, it's also in the topology of X prime cross Y prime. So then if we look at the images under pi 1, since they're open maps, pi 1v is going to be in T prime, and pi 1 of U is also going to be in U prime. Okay, for question 9. Okay, so if we let A cross B be our element in R2, and let's say A cross B is an element of some interval in the dictionary order, say A cross C, A cross D. So, and with B an element of CD, then this, we call this B, it's a basis element in R2 in the dictionary order. But also A cross B is an element of A cross CD. Let's call that B prime. Again, B an element of CD. Well, this is the basis element in D cross R. And we see that there's the same. We've got the same base. We've got quite obvious bijection between these two things. It's a homeomorphism, so they give the same topology. Okay, and how do we compare this topology with the standard topology? Well, since RD discrete topology is finer than R, then by question 5, RD cross R is finer than R cross R, which is R2.